At 10:02 in the morning on August 25, a sunspot near the center of the sun released the largest flare it had fired in 5 days. 16 solar flares in the preceding 24 hours, all from a single region. The largest triggered a radio blackout across an entire continent. And the plasma ejection that blast launched is now crossing space toward Earth. It is arriving the night of the lunar eclipse. But this is not the storm you think it is. The sunspot that produced this eruption carries a designation, AR4513. Its magnetic classification is beta gamma delta. The most volatile configuration that exists in solar physics. It sits dead center on the solar disk. That means any coronal mass ejection it fires travels almost directly toward our planet, and AR4513 just fired. The M7.0 flare peaked at 10:02 Universal Time. Some sources recorded as M6.98. Same measurement, rounded differently. Within minutes, short-wave radio frequencies across Africa went silent. An R2 moderate radio blackout. Aviation communication disrupted. Maritime channels dead. Emergency management frequencies offline for tens of minutes. That was the electromagnetic radiation. Light speed. 8 minutes from Sun to Earth. The coronal mass ejection takes longer. Much longer. Earth News Channel. Let's get into it. The CME is confirmed Earth-directed. Spaceweather.com and NOAA Space Weather Prediction Center both track it in transit. Arriba el forecast, sometime before dawn on August 28. The preliminary NASA model gives a window of 10 to 11 Universal Time. That is 6 to 7 in the morning Eastern Daylight Time. Uncertainty margin, 7 hours on either side. Forecasters describe this as a glancing blow. Slow-moving. A lopsided eruption caught on the sun's surface suggests the CME may not hit us head-on. But here is what those forecasts do not account for. A second stream of solar wind is also arriving, unrelated to AR4513. A coronal hole high-speed stream, expected to peak on August 28, the same night. When two solar wind disturbances arrive simultaneously, the high-speed stream can compress the CME's magnetic field and intensify its effects. NOAA had already forecast unsettled to active conditions for August 27 and 28 before the M7 flare ever occurred. That forecast accounted for the coronal hole stream alone. Now add the CME. And then there is the third element, the one that was calculated centuries in advance, the one that will happen exactly on schedule regardless of what the sun does. The lunar eclipse. The moon enters Earth's shadow at 2:33 in the morning Universal Time on August 28. Greatest eclipse at 4:12:55. Umbral magnitude 0.9319. That means 93.19% of the moon's diameter will be consumed by the darkest part of Earth's shadow. In terms of area, 96.3% of the lunar disk will go dark. Only a thin bright sliver remains outside the shadow. The eclipsed portion will appear dark red or copper-colored. This is the deepest partial eclipse since the total lunar eclipse of November 2022. The partial phase lasts 3 hours and 19 minutes. 3 independent phenomena. Same 24-hour window. A solar storm. A high-speed wind stream. A lunar eclipse visible across 2 continents. By the end of this report, you will understand exactly what this solar storm can do to Earth, why the lunar eclipse happening the same night changes the equation, and the one number that determines how bad this gets. A number that no forecaster on Earth can calculate in advance. Here is what we know. AR4513 erupted 16 times between August 24 and August 25. 5 of those flares were M-class, moderate-level eruptions capable of causing radio blackouts on the sunlit side of Earth. The sequence began with an M1.8 flare over the Pacific Ocean west of Central America, then an M2.0 over the Philippine Sea, then M1.8 over Southeast Asia, then M1.8 over the Southeast India coast. Each one triggered an R1 minor radio blackout. Then came the M7. The flare scale is logarithmic. Each letter represents a 10-fold increase over the previous. A-class is background solar activity. B-class is 10 times that. C-class is 100 times background. M-class is 1,000 times. X-class is 10,000 times. An M7.0 sits at 70% of the threshold for X-class. It is not a weak event. But the flare is not the threat, the coronal mass ejection is. There is one measurement, a single number. That will determine how bad this storm gets. It cannot be calculated. It cannot be modeled. The only way to know it is to wait until the storm is 15 minutes from Earth. To understand what that number is, you need to understand what a beta gamma delta sunspot actually means. Sunspots are classified by their magnetic structure. The simplest configuration is beta. Two magnetic poles, positive and negative, separated by a single dividing line. Stable, predictable, low flare probability. Gamma means the polarities are mixed. Positive and negative magnetic fields tangled together inside the sunspot group with no clear boundary between them. More unstable. Higher flare probability. Delta is the most dangerous. Delta means opposite magnetic polarities exist within a single sunspot umbra, the dark central core. Picture north and south magnetic poles crammed into the same physical space. This structure is under constant stress. It wants to explode. And it does. Delta sunspots produce significantly more and stronger flares than any other classification. This is the category most associated with X-class eruptions. AR 4513 carries all three designations simultaneously. Beta gamma delta. It has been classified this way since at least August 20. And on August 20th, it fired an M8.1 flare. Stronger than the M7 it just produced. That earlier eruption launched a CME with a shock velocity of 1,201 km per second, confirmed by Type 2 radio sweep. But on August 20th, AR 4513 was near the Sun's east limb. The CME fired sideways. Away from Earth, coronagraph imagery confirmed a large CME heading east into space. It missed. 5 days later, the Sun rotated. AR 4513 moved from the east limb to disk center. Same magnetic complexity, same flare capability, different geometry. This time it does not miss. A coronal mass ejection is not light, it is matter. Billions of tons of magnetized plasma ejected from the Sun's corona. CMEs travel at speeds ranging from 250 to 3,000 km per second, depending on the strength of the eruption. Transit time from Sun to Earth, 1 to 4 days. This particular CME is slow-moving. Forecasters describe it as below average speed. But speed is not the only variable that matters. What matters is the magnetic field the CME carries with it. The interplanetary magnetic field has three components. BX points toward or away from the Sun, by points east or west across the solar system. BZ points north or south relative to Earth's magnetic poles. BZ is everything. If the CME arrives with a northward BZ, its magnetic field aligns with Earth's magnetic field. The two fields slide past each other. The CME's energy flows around the magnetosphere. Minimal storm. Minimal aurora. KP index stays low. If the CME arrives with a southward BZ, its magnetic field opposes Earth's. Magnetic reconnection occurs on the dayside magnetosphere. A doorway opens. Energy pours in. The magnetosphere compresses. Currents surge toward the poles. Geomagnetic storm. Aurora. The stronger the southward BZ, and the longer it lasts, the worse the storm gets. There is no way to predict which direction the BZ will point. Models cannot calculate it. Simulations cannot forecast it. The only way to measure the BZ component is to sample the solar wind directly. And the only place to do that is at the L1 Lagrange point. It sits 1.5 million kilometers upstream from Earth. A satellite called DSCaver sits at L1. It measures the solar wind in real time. When the CME reaches DSCaver, the satellite transmits the BZ reading back to Earth. Warning time: 15 to 45 minutes before the CME impacts the magnetosphere. 15 minutes. That is how much advance notice forecasters get when the BZ turns southward. That is how much time power grid operators have to brace systems. That is how long aurora chasers have to get outside. The BZ cannot be known until the storm is already here. But what the M7 alone cannot explain is why space weather forecasters are quietly monitoring something else. Something that arrived from a completely different part of the Sun. Something that could make everything that follows significantly worse. Coronal holes are regions where the Sun's magnetic field opens outward instead of looping back on itself. Solar wind escapes freely through these open field lines. The wind accelerates. Background solar wind moves at roughly 400 kilometers per second. Wind from a coronal hole moves at 600 to 800 kilometers per second. A high-speed stream from a coronal hole is expected to reach Earth late on August 27 and peak on August 28. NOAA's forecast called for KP 3 to 4 conditions with a chance of reaching KP 5. KP 5 is the threshold for G1 minor geomagnetic storm. That was the baseline, just the coronal hole stream, no CME. Now add the CME. When a CME and a high-speed stream arrive at Earth simultaneously, the fast wind can compress the CME's magnetic field. If the CME already carries a southward BZ component, compression intensifies it. The storm escalates beyond what either phenomenon would produce alone. This is honest, not guaranteed. It depends on timing. It depends on alignment. But the window is there. So that's the storm. That's the mechanism. That's the variable nobody can predict. And under normal circumstances, this would be the complete story. A significant but manageable solar weather event arriving this week. Except these are not normal circumstances. The CME is forecast to arrive sometime before dawn on August 28. The exact window is uncertain. A 7-hour margin on either side of the preliminary model. But the eclipse has no uncertainty at all. The moon enters Earth's shadow at 2:33 in the morning Universal Time. Greatest eclipse at 4:12:55. By that point, 96.3% of the lunar disk consumed by Earth's umbra. Partial phase lasting 3 hours and 19 minutes. This eclipse was calculated centuries in advance. It will happen on schedule, and the CME is arriving in the same window. This eclipse belongs to Saros cycle 138. The same series last produced this eclipse in August 2008. The next one comes in September 2044. At greatest eclipse, only a thin bright sliver of the moon remains outside Earth's shadow. The rest glows dark red. Not gray, red. Because Earth's atmosphere bends and filters sunlight around its own edges, casting a ring of every sunrise and every sunset simultaneously onto the moon's surface. That filtered light is what gives the eclipse moon its copper color. It is the light of every horizon on Earth at once. The eclipse is visible across all of the continental United States except Alaska and northwestern Canada. All of Canada. Central and South America. Western Europe, Western Africa. Hundreds of millions of people in the direct viewing zone. Here is what most people are getting wrong about this combination. They assume the solar storm makes the eclipse worse, or that the eclipse somehow interferes with the storm. Neither is true. These two events are physically unrelated. The eclipse is orbital mechanics. The storm is solar plasma. One does not cause or affect the other. But there is a connection, and it runs the other direction. The eclipse may make the storm more spectacular. Here is why. A full moon is bright enough to wash out faint aurora at mid-latitudes. During a lunar eclipse, 96.3% of the moon's disk goes dark. The sky gets dramatically darker. Aurora at 45 to 50 degrees latitude. Normally invisible under moonlight. It becomes visible during eclipse totality or near totality. The same geomagnetic storm that would produce aurora only at 60 degrees on a normal night can show aurora at 50 degrees when the moon is dark. This is not speculation. It happened in March 2025. Total lunar eclipse. March 13 to 14. Northern Alaska. An aurora superstorm erupted at the peak of totality. Photographer Dan Zafra captured it. He described what he saw. As the landscape dimmed during the eclipse, the aurora intensified. Once totality ended, the landscape brightened again, and the moon's glow returned. It was surreal, magical, and unlike anything I had ever experienced. That was 18 months ago. Unplanned. Unforecast. A coincidence of timing. Tonight, a solar storm was forecast to arrive. The eclipse was known 2 years in advance. The combination is not guaranteed. But it is possible. And it is planned for. The same planet that created the aurora created the eclipse shadow. Earth's magnetosphere redirects the CME's energy toward the poles, where it generates the aurora. Earth's geometry blocks the sun's light from reaching the moon, creating the shadow. Both effects have the same author, this planet. But before you plan to go outside, there are 3 things about this situation that are being widely misreported, and one of them matters more than anything else forecasters are saying. The first misconception: solar flares cause earthquakes. You will see this claim circulating. It appears after every major solar event. The idea is that solar flares or geomagnetic storms trigger seismic activity on Earth. The science does not support this. Solar flares produce electromagnetic radiation. CMEs produce charged particles. Neither mechanism has a demonstrated coupling pathway to Earth's crust with sufficient energy to trigger earthquakes. Large earthquakes occur with equal frequency during solar maximum and solar minimum. There is no statistical correlation in the historical record spanning multiple solar cycles. Some researchers have proposed speculative mechanisms involving electromagnetic induction in rock formations. The mainstream geophysical consensus rejects this. The energy scales are incomparable. A major earthquake releases energy equivalent to billions of tons of TNT in Earth's interior. Solar storm effects measured at the ground surface register in microvolts per kilometer. The honest concern is not geological, it is technological. GPS, radio, satellites. The second misconception: the storm changes the eclipse color. This claim is more sophisticated than the earthquake myth, which is why it needs careful handling. There is a kernel of truth. Extremely intense geomagnetic storms can slightly modify Earth's upper atmosphere density, which changes how sunlight bends around Earth's edges to reach the moon. This effect exists in theory, but a G1 to G2 storm is not nearly powerful enough to produce a measurable color shift. Eclipse color is primarily determined by atmospheric particulates, volcanic ash, dust, humidity, not solar storms. The color you see tonight was set by the state of Earth's atmosphere long before AR 4513 ever fired. The honest answer: the eclipse will look the same as it would without the storm, and it will be extraordinary on its own terms. The third misconception: this storm will damage the power grid. Solar storm hitting Earth. The same framing applies to every event from a G1 to a G5. The scale is not communicated. G1 effects: weak voltage fluctuations at high-latitude power systems. Polar satellite operations marginal. G2 effects: voltage alarms possible at high latitudes. Satellite drag increases at low Earth orbit. These are real effects. They are manageable. Grid damaging threshold: G4 to G5. The 1989 Hydro-Quebec blackout was a G5 event. The March 1989 storm left 6 million people without power for 9 hours. That required a prolonged, intense southward magnetic field sustained for hours. The May 2024 G5 storm was the strongest in 20 years. Spectacular aurora visible worldwide. Zero grid failures. Modern protective systems engaged before the storm arrived. Power engineers have protocols. They use them. This CME is a slow-moving glancing blow. The honest forecast is G1 to G2. That is real. That has real effects on GPS and radio. It is not a grid event. What the data does support: HF radio disruption is real and ongoing. The R2 blackout already occurred on August 25. GPS accuracy degradation during geomagnetic storms is real. It affects aviation precision approaches, agricultural GPS-guided machinery, marine navigation. Satellite drag at low Earth orbit is real and requires orbit corrections from operators. Potential aurora at unusually low latitudes is real. If BZ turns southward during the eclipse window. And the ongoing X-class threat from AR 4513 is real, because the sunspot that fired this storm is still loaded, still aimed at Earth, and it has not finished. AR 4513 remains near disk center for the next 3 to 5 days. Its beta-gamma-delta magnetic classification persists. On August 21st, NOAA estimated a 10% probability of X-class flares from this region. That was before the burst of 16 flares on August 25. The probability has not decreased. Solar Cycle 25 has produced 104 X-class flares to date. The cycle peaked in October 2024 with a smoothed sunspot number of 161. We are in the declining phase now, but activity has not stopped. AR 4513 demonstrates that major active regions still form during the decline. This region has been firing since August 19. It has not exhausted its magnetic energy. Any X-class flare from disk center launches a CME directly at Earth, multiple CMEs arriving in sequence. This is the cannibal CME scenario. The second CME overtakes the first. They merge. The combined storm is stronger than either alone. The first CME clears the path. The second hits a magnetosphere already disturbed. That last point is the one forecasters are watching most carefully, because the sunspot that fired this storm is still loaded, still aimed at Earth, and it has not finished. Here are 5 specific signals to monitor. First, the KP index in the 6 hours before eclipse peak. NOAA's Space Weather Prediction Center updates this in real time at spaceweather.gov. G1 threshold is KP5. If KP reaches 5 or higher before 0412 UTC on August 28th, aurora is possible at high mid-latitudes during the eclipse window. Seattle, Minneapolis, Edinburgh, Scottish Highlands. Second, Scover satellite busy. Reading when the CME arrives at L1. If busy turns strongly southward, below -10 nanoteslas. Storm intensification is underway. This is the signal. Everything else is prelude. Watch it live at the NOAA real-time solar wind dashboard. Third, AR4513 flare output. Any new M7 or higher from disk center before August 30 means a second CME potentially in transit. 2 CMEs arriving in sequence means cannibal CME scenario. Storm escalation beyond the current forecast. Watch the NOAA swap flare alerts. Fourth, coronal whole stream arrival timing. If the high-speed stream arrives simultaneously with the CME, rather than before or after, the compound effect is maximized. Watch solar wind speed at L1. Any reading above 600 km per second combined with southward BZ is significant. Fifth, local cloud cover for eclipse viewing. 96.2